All right, ladies and gentlemen, this is Miss Swanson, and we're going to go through a couple of osmosis practice problems. These are the types of problems that you will need to be able to solve. And there's two basic things that you're going to need to know. And one, for each osmosis problem, you want to be able to tell me, is the cell or the solution hypertonic, hypotonic, or isotonic? Okay. And you can say the cell, or sometimes we're going to ask, is the solution? So if we're looking at this particular first problem, obviously if we're asking if the cell is hyper, hypo, or isotonic, we're referring to this shaded area in here. And if we're talking about is the environment hyper, hypo, or isotonic, we're referring to the environment out here. Okay, so that's important just to note as we go forward here. The second thing that you want to be able to tell me about each of the problems is, where is the water going to go? So you have a couple of different options here. And our first option is that water would go into our cell, right? And as our water goes into our cell, it's going to get bigger and it's going to expand. Our second option is that water is going to leave our cell, and in that process, the cell would shrink. And then finally, our third option is that water would go out and in at equal rates. So for each of these osmosis problems, you're going to tell me two things: is the cell or the environment, depends on what the problem asks. Is it hyper, hypo, or isotonic? And then the second thing, where is water going to go? So let's practice solving our first problem. So I'm going to show you how I like to approach these problems, and how I do it may be slightly different than another teacher. And just like it works with math, is that there are sometimes just different ways to solve similar problems. So let's read our first question here. If a cell contains 85% water and is placed in a solution, which is 50% water, is the solution hypotonic or hypertonic? So remember, it's asking here, and I like to even highlight so I know exactly what I'm trying to solve. I'm looking for the solution, and the solution is this outside portion. So the way we're going to set this up is as follows. I'm going to erase my stuff there. Is I like to show this out. So my cell contains 85% water, and I like to label that, and the solution has 50% water. Well, first of all, we know that osmosis is the movement of water, and osmosis goes, water moves from an area of high concentration to an area of low concentration. So with this problem, I can already tell you where water is going to go, because I know that 85% is high, and I mark it with an up arrow, and 50% is lower than 85%. So immediately I know that water is going to go from an area of high concentration to an area of low concentration. Therefore, my water is going to leave my cell. Now, some of you already remember if water leaves a cell, what kind of a solution that is. But if you haven't memorized that, and you don't need to, there's a quick way to figure this out. So the way that I like to do it is that I already know my concentration of water, and solute is an inverse relationship. So if water is low in the solution, I know that I have high solute. If water is high inside my cell, I know that my solute is low. And once again, our question asked, what is the solution? And anytime we are looking at hyper versus hypotonic, we are referring to the concentration of solute. Concentration of solute. So, remember, hypo means low solute. Hyper, if you eat lots of sugar, it's lots of solute. So the question says, is the solution, so this outside area, hypo or hyper? We look, it has a high arrow, therefore it is hypertonic. Water is going to move based on water concentration. We classify our types of osmotic solutions based on solute concentration. And that's the hardest thing that students have in terms of remembering that. All right, and we've already identified which direction the water will move. The water will move out of the cell, and the cell will shrink. All right, if you want to try to pause this video and go on to question number 2 and try to solve that on your own, I will talk you through it in just a second. So let's look at the second problem. A cell contains 85% water, so immediately I write in my 85% water, and is placed in a solution that contains 90% water. Check your own work as I go through this problem. Immediately, I figure out where is water high, in high concentration, and right here in the solution, it is high concentration, that's 90%, and this is lower than 90, so that's low concentration at 85% water. So first thing, which direction will water move? Once again, we know that water moves through osmosis from an area of high concentration to an area of low concentration. Therefore, water is going to move into our cell. So it moves into our cell, and we know that when water moves into our cell, it's going to get bigger. It's going to swell. All right, the second part of the problem, remember, we always have to figure out what kind of a solution is it. Is it hyper or is it hypotonic? So once again, these types of osmotic solutions are referring to the concentration of solute. Solute. So the dissolved, remember the dissolved particles in the solution. It was our Kool-Aid or our lemonade. So it's an inverse relationship. So if water is high outside the cell, I can also figure out the percentage. So if water is 90% outside the cell, well, it's a percent. So that means that my solute is actually 10% because 10 plus 90 equals 100%. Those are always going to equal 100. All right, so then I look inside my cell and it's 85% water. I'm looking for 100 total. So that means my concentration of solute is 15%. And then I want to identify. 15 is high. Once again, you can just look. It's an inverse relationship. If water is low, we knew it had to be high. And 10 is lower than 15. So the solute concentration outside the cell or in the solution is what it's asking for, is low solute. If you're below your body temperature, therefore you are hypotonic. All right, so our solution in this one is hypotonic. Let's look at our final problem. If a cell, which contains 90% water, is placed into an isotonic solution, and we remember that isotonic means equal. What is the what percentage of the solution is water? So if our cell contains 90% water, how it would be equal, and what that means is equal on both sides. So people always want to think equal, it's 50%, okay, the concentration of water. But if water is 90% inside the cell, the way that it's going to be equal is that it's going to be 90% outside. Therefore, water in this particular cell is going to move out and in at equal rates. And the size of the cell is not going to change at all. So here are some additional practice problems. What you may want to do is pause this video, go through and answer all the questions that you can, show your work. It's really important so you know if you get something wrong, where was the error in your thinking. So pause this video and then I will go through at least the first 3 problems and show out my work, and you can cross-check it to your own. All right, welcome back. I'm going to go through the practice problems, and you can check my work to your own and see if you did them correctly and you got the same answer, or you can see where the error in your thinking was. So for our first problem, I'm going to draw it out here, and you can look at your own work once again. Here's my beaker, and there's my cell. And in this problem, our cell contains 85% water, and it's placed in an environment with 50% water. And I always label water versus solute. It helps me keep track of what is what. So immediately, you can figure out which direction the water will move. So 85% is the high concentration, 50% is the low concentration of water. Therefore, water moves from an area of high to low. So water is going to move out of our cell. Water moves out. All right. The second thing we need to do is we need to look at the solute concentration. And we know that if water is high inside the cell, that means my solute is going to be low. And if water is low in the solution, I know that my solute has to be high. Once again, if we describe hypo-isotonic solutions, which are osmotic solutions, we look at the concentration of solute. Solute. So in this particular question, though, let's see if I can move and look at what the question actually says. In this question, it says, is the cell hyper or hypotonic? Is the cell? So I look inside my cell and I see that it has low solute. Therefore, the cell equals low hypotonic. All right, if you got hypertonic, you probably said the solution or the environment was hypertonic. And that is right, but it's not what the question was asking. So if I look outside in my beaker, it is high solute. If you have lots of sugar, you're hyper, but make sure that you read carefully. I'm going to move on to number 2. Number 2 says that a cell contains 85% water. So 85% water, and it's placed in a solution with 90% water. And this one says, is the environment hypo or hypertonic? So that's this outside portion. So once again, let's figure out immediately where is water going to move. We see that water's high here. 90 is higher than 85. And immediately we know that water is going to move from an area of high concentration to an area of low concentration. So therefore, water will move into our cell. So water moves into our cell. And then once again, we want to figure out the outside solution. So I know that, let's go over here to a different color. If our water is high outside, that means my solute is going to be low. If my water is low inside my cell, my solute is going to be high. Therefore, I look on the outside because I look in the environment and I have low solute. If I am low solute, I am hypotonic. hypotonic environment. So hopefully this is becoming a little bit easier. Eventually, you're going to start to see some trends. One little helpful hint is whatever is hypotonic, so if it's the solution or the environment or the cell, water is always going to be leaving that area. And the way that we remember that is hypo, water's gotta go. So let's double check our answer using that little device. So hypo, if our environment is hypo, like we see here, because it has low solute, it's gotta go. And that's exactly what it's doing. It's leaving this solution and it's going into my cell. So let's go back and even take a look at our, I'm going to show you one last practice problem here. Number 4, we're going to skip down to number 4. And in this one, a cell contains 95% water. And the environment outside the cell contains 45% solute. So this one's a little bit different than what we've been looking at. And our question asks, is the cell in a hypo or hypertonic environment? Okay, so once again, we're looking at the outside part. So this problem is the first one we've seen where the solute and the water concentrations have been given, and we need to figure out the solute and the water concentration for the other component here. So let's take a look. So if we know that we have 45% solute, therefore we know that our water concentration has to equal 100 total. So 45 plus, well, that would be 55, if I'm correct here, equals water. Okay, once again, so now our solution equals 100% total. So 55 plus 45 equals 100%. And then inside our cell, we have 95% water, and that leaves us with 5% solute. So 95 plus 5 equals 100%. Right? We have 100% concentration inside our cell. We have 100% concentration outside our cell now. Okay, so we go back to solving the problem like we have done in the past. So the first thing easy to look for is where is water high and where is water low. So water on the inside of our cell is 95%, and that is higher or greater than 55%. And once again, water moves from an area of high concentration to an area of low concentration. Therefore, water is going to move outside our cell. So water moves outside of our cell. Water, here we go, moves out. Our cell shrinks. And now we want to know, is the environment hyper or hypotonic? So we look on the outside. This is pretty easy. We look on the outside and we have 45% solute, and that is higher than our 5% solute. Okay, or we can just look at that is high, and because this is low, it's an inverse relationship once again. And if we have high solute or we eat lots of sugar, we are going to be hypertonic. So our environment for this problem is hypertonic. That means that our cell, if we look right here, is hypotonic. It has low solute. It's just going to be opposite of the solution. I'm going to quickly go through the rest of the answers so you can double check your own. Number 3, we skipped over, but 90%. The solution would therefore also be 90%. Moving on to problem 5. Water is going to move out of the cell. That means that the cell is hypotonic and the environment is hypertonic. It doesn't ask you that question, but I put that down. Number 6, let's look. It's water moves out of the cell, and the salt solution therefore is hypertonic. And finally, if water leaves the cell when placed in a solution, the cell is hypotonic. Just remembering the little device, Hypo, water's gotta go. All right, hope this helped.